This is an introduction to designLED technology and its capabilities. We start with a short animation describing the fundamentals and basic device structure, and then go on to show some real-world examples. Here are the fundamentals of our printed light guide technology. We start with a transparent substrate. We print optics, electrical tracking, and mount LEDs. This printed foil is then encapsulated with a transparent polymer, forming a light guide structure with the LEDs inside. We sometimes add additional optics by screen or digital printing, for example, to hide the LEDs. We turn this light guide component into a lighting system by adding a reflector and diffusing our decorative layers. If the LEDs are turned on, the light is guided through the transparent layers and then extracted by the optics. The result is a homogeneous illuminated surface with a very thin construction. We can also use RGB LEDs for 2D dynamic effects, and the device can be mechanically flexible or 3D. What now follows are some real-world examples. Here we see a light tile designed for outdoor lightbox applications. It shows the thinness, mechanical flexibility, LEDs embedded inside with printed electrical tracking, and optics on the surface to control the light distribution. The technology delivers a full lighting system in a foil platform, which has a wide range of uses and applications. The example shown here has prism optics on one surface, producing a narrow beam angle shelf light product. Here is another light tile configuration showing a dense array of white LEDs with optics to spread out the light and to hide the LED hotspots. The manufacturing process is additive, and you can see the LEDs inside the transparent polymer layers with the printed electrical tracking. The optics in this sample has been configured to deliver uniformity to diffusers or other materials placed directly on the surface. We see this homogeneity or stopping the LEDs being dotty as a key USP of the technology. And here we can see the uniform backlighting of a decorative material. Other types of LEDs can be used. Here we see an array of smart LEDs where each LED has a red, green, blue LED chip as well as a driver IC inside the same package. So each LED is individually controllable. We add optics to spread the light evenly and to reduce the LED hotspots. So when we place a decorative surface on top of the light tile, we can achieve a very nice homogeneous result. Here are two RGB light tiles mounted together behind a decorative surface in a curve. This shows that thin, curved and modular solutions can be produced, where standard light tiles can be joined together optically, mechanically and electrically. Here we configure the technology with smart LEDs into a trim backlighting use case. We show edge-to-edge homogeneity around obstacles in a complex and curved shape. We demonstrate that a wide range of automotive interior materials can be effectively backlit. These include wood, leather, cloth, metallized surfaces, fake stone, plus in-mold decorative and in-mold labelled parts. Secret to lit effects are very attractive. Surfaces can be given a day and a different nighttime appearance. we look under the decorative surface inside this demonstrator, it has a high density of LEDs. LEDs are one of the key cost drivers for this type of use case. The use of designLED optics and the light guide allows the LEDs to be spaced far apart, but retain same levels of uniformity, perhaps with a lower light level, and we can see that there is a similar level of 2D dynamic effect across the demonstrator, but with only 10 smart LEDs in this case. We see this reduction in LED count and hence cost as a key USP. designLED's technology portfolio also includes the integration of capacitive touch sensing, which enables interactive decorative human-machine interfaces. Here we show a demonstrator with illuminated icons behind a thin wooden veneer. The portfolio also includes the integration of other sensors, communication and intelligence into the light tile, turning a comparatively dumb light source into a fully interactive smart surface.